let's go ahead and get into it here. So a lot of you have been to my percent classes before, but let's go ahead and refresh on this. Everybody, quick question. Percent. That means out of what number? Out of what number? That's right. Percent means out of 100, okay? Out of 100. And this is way too important. For those of you that are at least familiar with percents, is it true or is it false that the majority of percent problems, you're always referring to 100% as like your basis? For every tax and for every discount problem, you're always referring to that 100%. Right. And the one thing that we can, let me just write this down first. But we can really just attribute this to just basic conversations that we have with other people. Yeah, I'm feeling 100% today, right? I'm feeling like all of myself today. So when you think about it that way, just think about 100% as the starting point, the whole thing, the starting amount. If you think about it that way, you're really going to see how I'm going to relate percents to proportions later. And it's not necessary to understand that to be successful with percents, but it is going to help you solve a lot of problems quicker if you do know this. Hey, really quick before we continue, if you're watching this, you've likely already been to one of my classes. And if you haven't been to one of my classes, remember to check that schedule. The link is right up there and in the description of this video. That way you can understand when my free classes are and my Access program classes are. That way you can keep raising your score, knowing what topics we're doing, and get the job you want. So again, click there or in the description to see when the classes are and join one for free. I'll see you there, my party people. Let's get back to the action. So let's go ahead and go over this real quick. Finding the percent of a number. Go ahead and take these notes down, please, and thank you. Step one in finding the percent of a number. Remember that, oops, excuse me there. Step one in finding the percent of a number is, well, you got to convert that percent to a decimal. Remember this, and again, write that down right there. Anytime you are taking the percent of a number, before you multiply, you got to make sure you turn that percent to a decimal. A percent is not the right form to include in an expression with multiplication and things like that. You got to turn it into its fractional part or decimal in a sense. So if that didn't make too much sense, no worries. The easy way to do it, easy way to remember it is just by taking that decimal and move it 2 places to the left. And we're going to go over an example right now. I got you. But really, again, turn that percent to a decimal. Like taking that decimal place twice to the left, you're good. Step number 2, super straightforward. Multiply. That's it. Now, again, I'm showing you the forward way right now. We are going to go over the backwards method. We are going to go over that. And again, we're going to keep developing a sense of the basics. That way, when we get to those word problems, we're having a little bit of a time. So let's go ahead and go over an example real quick. And then we are going to go over going forward and going backwards, like how to find the original versus the result. So everybody, let's just go over this example here. 50% of 20. Now, really quick, what did I say the original percent is, everybody? What percent represents the whole thing? 100, right? Okay, so let's just talk about this in English. And I hope that everybody's participating here. When you go from 100% to 50%, this might seem pretty easy, but let's just answer it honestly. What is 50 to 100? Like, what relationship is 50 to 100? Look at those comments there in the chat box. Okay, like this seems very intuitive, right? Seems very straightforward right now. When the numbers get crazier, it might not seem, but it's still the same thing. So pay attention here. 50% is half of 100. And question again, when I said 100%, 100% represents what? What does 100% represent? The whole thing, right? 100% of myself, right? 100% is the whole thing. So if you're trying to take 50% of a number, what does it sound like you might be doing to that number? If you're taking 50% of a number, what does it sound like you might be doing? Right, you might be cutting it in half. You might be taking half of that number. And so everybody, quick question. What's half of 20? Right, half of 20 is 10. There's our answer right over here. There's our answer. So when I said that proportions and percents are very similar ideas, they're actually one and the same. So just take a look at that. 50% of 20, which really can sound like you're saying take half of 20. That's true. It's proven to be true. When you do that, you get 10. Who here did not know that you could think about percents in that way? So did you, yes, or did you not know? And again, this is for me, this is to dictate the way that I teach this. Yeah, and if you didn't know and now you do, yeah, you can definitely go ahead and say that, please and thank you. Okay, sounds good. So we're going to get into this more and more again when we see convenient situations to apply this, especially tomorrow as well. So if we don't go over too many examples, don't worry. Let's go over the straightforward, straight up and down method, and then we'll continue adding in some of those shortcuts later. So here we go. Step one, like we said, just convert that percent to a decimal. And again, the shortcut way, take that decimal place, move it over to the left 2 times. So here we go. This is where you would spot the decimal. If you have 7, that's the same thing as 7.0, right? If you have 50, that's the same thing as 50.0. So that's where your decimal is. Even though you don't see it, it's still there. And then all we're going to do, move it over to the left 2 times. Everybody, what does that turn into? If we take 50%, turn it into a decimal, what is it supposed to be? What do you think? What do you think it's supposed to be? Right, 0.5, 0.5, 0.50, 0.50, all of those are correct. Every single one of those are correct. So as long as you move it over 2 times, 1, 2, you have 0.5, 0.50, 0.5. It's all the same thing. Don't worry. Those extra zeros are really just extra zeros. So that's where you turn it in right here. 0.5 times 20. And all you're going to do is multiply. So here we go. We can go ahead and take it right here. 20 times 0.5. Again, you can multiply by 0.50 if you wanted to. That's only going to give you extra work to do. You're still going to get to the same answer. So I'm going to elect to not include that extra 0. And so with that, let's get into it. 0 times 5, that's going to be 0. And then 2 times 5, 2 times 5, it's going to be 10. Sounds good. And it looks like the answer is going to be 100, but it's not. Let me remind you about how to multiply with decimals. Everybody, what did I say? If you've watched my videos on multiplying with decimals, what did I say? Step 1, ignore the decimal and just multiply. But what do you have to do at the end with all those decimals? That's right. You got to bring the decimal places back. As many decimal places as you had, you bring them back. So if I zoom all the way in here, everybody, how many decimal places is this? How many decimal places? Right. In this case, just 1. Just 1. In this case, just 1. And so that's why we have 100, but it'll actually be 10. And that's how we get 10. Right here. Boom. And so just to review again, I know this seems very, very repetitive to some because we've had the practice, but again, you know how things go in the classes, we ramp it up as time goes on. But again, step 1, always make sure to turn that percent to a decimal. Step 2, multiply. And just a refresher with multiplying with decimals, just ignore it, bring it back at the end. Yes or no, are we feeling okay at the very least in terms of starting with percents here? And all we did again was just multiplying by a percent. And again, be honest, it's all good. No worries, Alexis, I hear you. And again, we'll go over plenty more examples. I'm definitely going to make sure we pause wherever needed. Okay, so here's the second thing that I want to remind you of, and I'm doing this on purpose. Everybody, what percent represents the whole thing again? The whole thing? Cool. Yep. 100% represents the original number of the whole thing. Again, keep that in mind as we go forward. If you're having a little bit of trouble multiplying with decimals, don't worry. We'll have plenty more opportunities. We'll continue going over those rules, okay? So here we go. Number 2. There are the formula that you can use, and I know I wrote two formulas. I used to have another one right here, but I took it off because it's really not necessary to get this 1000% correct. So just the formula you can use, I'm going to go ahead and just mark this right over here. The formula you can use is basically your percent times your original number equals the result. So if you're trying to find out what 20% of 9 is, it's 20% times 9 is going to give you what the result is. Now, the big question that you should be asking, if you haven't already, is how do you know the difference between the original number and what the result is gonna be? Yes or no? Has anybody here ever had that question? How do you know which number is the original number? How do you know which one's the result to even apply this formula? And again, honest responses only. Honest responses only. And it's all, no, don't worry about it. It's all good. Welcome in. I love that. Max right there. You might notice what the original number is and what the result is by the language of the problem, because you always take the percent of a number of the original, and then the word is tells you what the result is going to be. So excellent job there, Max. Appreciate that. But we're going to continue going over that time and time again. So if you didn't quite catch that, I'm going to write it down in a brief moment. But go ahead and write this down here. You're working forward in red over here. You're working forward or multiplying right over here when you're trying to find the result. So if you notice in the equation, you're multiplying the percent times the original to get the result. So you apply the percent to find the result. So if you're trying to find the result, you're multiplying. If you're trying to go backwards or find the original number, you're going to divide. So just a quick example to show you what I mean by that. And then number two, I'm going to go back to those keywords that I just talked about. I see you in the chat box. I'm going to go ahead and go back to the those examples that I gave for how to know original versus result. So just a quick example here. Everybody, I think we can get behind this example here. I think we can go ahead and say, if I said we got 2 times x equals, let's say 60. Everybody, if we're solving an equation like this, I know it's a little off topic, but this is very relevant. If we're trying to solve this equation over here, 2x equals 60, my party people, what are we supposed to do to both sides to get the x by itself? What are we supposed to do? Right, for those of us that have had experience with solving equations or have that refresher there, you're working backwards. And so if you're looking at this example, 2 times x equals 60, again, read that again, 2 times x. These are being multiplied together. When you see two values attached together with no operation, it's multiplication, it's just not shown. So you got 2 times x equals 60. To get the x by itself, you got to work backwards. Now, why am I placing so much emphasis on this example? Because it's the same thing here. Same thing here. Because you'll get rid of the 2, you'll get the x by itself, and everybody 60 divided by 2, you know what it is. Hit me. Yeah, it's going to be 30. It's going to be 30. Booyah. Nice and easy. And we're set. So with that said, why did I show you that example? Well, here you go. If you need to work backwards, let's take a look at the formula one more time. Let's suppose that you need to work backwards. Let's suppose that you're trying to find out what the original number is. Well, if you're trying to find out what the original number is, everybody, you got to get rid of the percent. And everybody, true or false? Right now, that percent is being multiplied by that original number. In that formula, the percent is multiplied to the original number. True or false? True, right? True. Percent is clearly being multiplied. So if you're trying to work backwards, or if you're trying to find the original number, the beginning amount, notice how you would need to divide both sides by the percent. You would need to divide both sides by the percent to get the original amount by itself. So this is just a quick example of understanding how to solve it. Once you know whether you're looking for the original or the result, this is how you do it. If you're trying to find the result, you're multiplying the percent by the original and you're going. If you're trying to work backwards to get the original number, well, you got to get rid of the percent by dividing. Even if you're not confident in how this looks in practice, can you get behind the idea, yes or no, that when you're working forward to find the result, you multiply, working backwards to find any original amount, you're dividing? Yes or no, does that make sense for you so far? Even if you don't see it in practice yet, can we have that written down and ready to go? Again, kind ofs work, a no works. Again, be honest, that's all I care about, okay? That's all I care about. Gotcha. Cool. And again, if you're still a little confused, no worries, just keep taking those notes. When we get into that practice, we're gonna have a good time. So those things that I was talking to you about earlier in terms of those keywords for finding the result versus the original. Whenever you say 20 or blank percent, so whenever you have problems, there's a couple different problems that you can actually write out. And here's one. What is blank percent of blank? So if it's written in that form, we are looking for what, everybody? What do you think we're looking for? Looking for the original or the result? If you have a problem structured in that way, what is blank percent of blank? Do you think we're looking for the result or the original? What do you think? Again, just asking for your opinion. If you're not sure, give a guess. Give a guess. It's all good. Okay, so for those of you who said result, you're correct. You're correct. But even if you got it wrong or were lucky in taking a guess, it's very important that we understand the why. So follow along. Everybody, quick question. Which two things are being multiplied in the original equation? So in this formula right over here, let me move this out the way. In the original formula, what's being multiplied? Is it the percent in the original or the percent in the result? Which ones are being multiplied together? The percent multiplied by the original or by the result? Right, the original is being multiplied by the percent. It's always the percent of the original number. That's how you get the result, right? That's how you get the result. So just take a look at the way that this is written. What is blank percent? So that's clearly a percent, right? There's no argument there, right? But here's what we need to take a look at. Everybody, in math, the word of means what? Multiply, right? The word of in math means multiply. So if you're taking a look right here, that's multiplication. And everybody, what do we know? The percent multiplies with the original to give you the result. The percent multiplies with the original to get the result. And that's how you know. If there's a problem that says, what is 2% of 90? What is 50% of 76? What is this percent of this number? That's telling you that you're trying to find a percent of this number and you're looking for the result. Does that make any more sense to anybody here? Again, it's really about noticing how this is structured, because if you're not focusing on this right now, I can guarantee you might have a little bit more trouble than you should later on. The mechanics of the basics are way too important. So again, one more time, do we see how, again, seeing the word of multiplication tells you that you're multiplying the percent with the original? They're asking you for the result. Okay, so here's another way, another problem, another template that you might see. Another one might look like this. Another one might be blank is what percent of blank? So here, what are you being asked to figure out? First of all, do you know what you're being asked to find? Are you being asked to find the percent, the original, the result? What are you being asked to find here? So for those of you saying original, not quite. You're actually looking for the percent in this one. So let me just highlight this and it'll make a lot more sense. I got you. It'll make a lot more sense once I highlight that you're asking to find So let me actually fill this in. You can say like 20 is what percent of, let's say, 80. If I fill this in, blank is. Everybody in math, the word is means what? Right, the word is means equal in math, right? Okay, sounds good. And so everybody, is it true that if I say 1 + 1 = 2, I can still say 2 = 1 + 1. I can flip it over, right? 1 + 1 = 2, 2 = 1 + 1. So I could just write this formula like this. The result is the percent of the original. That handwriting is not my proudest, but there it is. Let me actually fix that up for you. I got you. So everyone, in this way, if I structure it this way, can you see that we're given the result, the what percent part of it, that's what's unknown, that's what we don't know. And then we see here, 80. Do we see it in this way? Does that make a little more sense to anybody out there? That in this case, we're looking for the percent. We're looking for the percent. Does that make a little more sense here? Now again, I'm not asking you if you know how to calculate it. I'm not asking you at all if you know how to calculate it. I just want to know that you can read a sentence and tell what you're looking for. Again, this is one of the biggest problems with percents, and that's what we're going to focus on today. Sort of, kind of, maybe. Okay, good. Thanks for being honest, first of all, because we're going to work on that. Good. Now here's one more. So we have, again, just to go over it, number 1 right over here. What is blank percent of the original? Number 2, 20%, blank is what percent of blank, looking for the percent. And number 3, and these are the common ones, you could say that blank is blank percent of what number. This is the most common one that you'll see, especially when they're trying to trick you and get you off your feet here. So here, just doing the same thing that we did. For sure, Glenda, I got you. Give me one moment. So let's just think about this one more time again. Everybody, what's by itself in the formula? On one side by itself, is it the original? Is it the result? What is by itself? What is by itself here? So I'm going to go ahead and show this and then let you change your answer if you need to. Take a look at the formula. Which one of those things is by itself? The percent, the original, the result. Which of those is by itself? Right. And everybody, again, what was a key word for the word equals again? What's a key word for the word equals? Is, right? So is it possible to see that the word is separates the original times the result and or the original times the percent and the result. The result is by itself. Take a look over here. Is, what that means is this right here is the result is, what percent or whatever percent, and then what number. Everybody, can you remember that of means multiply again? The word of means multiply, and you always multiply the percent by the original number. Can you see that right here? What number, quote unquote, what you're looking for here is the original. Yes or no? Does that make sense to you here? Result equals the percent of your original number. And so if we look at it this way, again, it's really all formulaic. It's about noticing structure. If you can work to notice the structure here, once we get into these word problems, I promise you, you're going to be like, oh yeah, okay, this method, but it's going to be a little repetitive, okay? And that's correct. If we want to get that original number by itself, we're going to have to divide both sides by that percent, exactly. The reverse of those will get you, Shirley? No worries. There are a lot of people here on the same boat as you are. That's why I'm exposing or really being repetitive on the structure. And then when we get into the calculation, we'll go ahead and see where this really guides the way for us. Okay, so just to review one more time, all three here, let me actually get myself out of the view, and then we're going to get into some example problems right now. So let me get myself out of view, and we're going to focus again right here, these three. Take a quick screenshot or picture. That way you have that up here on the right side. So number one, again, if you're looking at a problem that says, what is 10% of this number? You're looking for the result. The word of is in there telling you to multiply that number that you have as the percent and the number you have as the original to get that result. Some problems might actually have you find the percent. So they might give you the original number right here, or they might give you the original number. They might give you the result, and then they say, what percent? What's the percentage? If they say what percent, you already know you're looking for the percentage, but it's more important that you can identify which of these is the result, which of these is the original. Because again, even if you know what you're looking for, you got to know how to do it. So you're asking, hey, should I divide 20 by 80 or 80 by 20? Which way should I do? That's also very important again, guys. So noticing again what parts belong where. Lastly, number three, this is an example of us looking for the original number. So remember that the result is, or whenever you see the word is, whatever's standing by itself, that's the result. So right here, the result is the percent of some number. And in this case, we're looking for that number, that original number in this case. So I understand full and well that we may not be ready to calculate, but we are going to right now. We're going to do it. We're going to practice this. But make sure to have this down so you can at least spot what you're supposed to do. All right, I'm going to give this 10 more seconds. Take your screenshot, and we're getting to these examples right now. All right, a few more moments here. 4, 3, 2, and 1. And sorry for bringing my ugly face back into this. Let's go ahead and let's get into some examples here. My ASVAB party people, hope you're enjoying the math party so far. Just wanted to remind you before we continue that we do have a way for you to practice everything you need to get the ASVAB score that you want. Because in our math boot camp, we have everything you need in terms of recorded lessons to go through the entire concept. On top of that, we have guided practice, printable worksheets, and speed drills for each and every single mini concept, from adding and subtracting decimals to fractions, distance, rate, time, word problems, proportions, everything you need. It's all lined up for you, and it makes learning as easy as possible, and we make updates to this course on a weekly basis at no extra cost to you. So I really urge you and implore you, go ahead, check out the link in the description for the Math Bootcamp, which is also included in our full program, and we make it as affordable as possible. So go ahead, click the link in the description to learn about this more. That way you know exactly what's available to you to raise your score. I don't want you to feel test anxiety. I don't want you to feel like you're lost and you're just hoping for the best. I want you to take control of your studying, and the ASVAB All-Access Program and the Math Bootcamp are the exact ways to do it. So if you have any questions, my contact info is also in the description. But before we continue, please check it out so you know exactly what's available to you. That way you can feel confident that there is a solution for you. Let's get back to the video though. Let's ace the ASVAB. So before we even do the calculations, before we get into that, let's look at the first one here. What is 20% of 168? Everybody, quick question. What do you think we're looking for? The percent, the original number, the result? What do you think? What do you think we're looking for here? And now go ahead, retype your answer and then give me a reason why. Why do you think your answer is the correct answer? Whether you wrote percent, whether you wrote result, whether you wrote original, I want to know why. I want to see at least a few different answers here. Let's see. Ooh, someone made a pretty good point there. The 20% of 168. The 20% and 168 are together. Yep, exactly. I love these reasons. There we go. This is showing that a lot of you are going to make that progress that you need to make. Again, reasoning is very important. Understanding the why, being able to state why. Let's go ahead and understand what the answer is here. Here, everybody, we're looking for the result. We're looking for the result. Here's how I know. Everybody, when they say what, are they giving you a number, or are they saying that that number is not yet known? Right, that's not yet known, right? And sorry about this not behaving for some reason. There's like a dead spot on my iPad. There it is. All right. So yeah, when you say the word what, you're basically saying some number, right? Something belongs here. So what? I don't know what it is. I'm gonna write a blank there. Everybody, the word is, what does that change into in terms of math? What does that change into? Changes into equals. Okay. Okay. So even for those of us that are confused, those first two steps should be very understandable. When you see what or what is or whatever, that's an unknown. I'm going to leave it blank. Number two, the word equals or is, those are synonymous. Is and equals, same thing. Then we see 20% right over here. So there's my percent. Everybody, quick question. The word of means what? Multiply. That's right. The word of means multiply. So let's go ahead and highlight that right there. Times. Okay. And then everybody, quick last question over here. 168. That's just 168. We're multiplying. The word of 168 means multiplying by 168. So everyone, if we go back to our little formula, the percent times the original equals the what? The result. It equals the result. So before I continue, does it make sense to you here that in this problem, we are looking for the results? We're multiplying 20% by 168 to get the result. Again, I know it's going to take time. I know it's going to take time, and I know some of us are a little ahead of this. I get it. Just understand that at 7:05-ish, we're kicking straight into those word problems if we're not there already, and it's going to be a good time. So don't get ahead of yourself here. Make sure that you, again, be meticulous about these details here. Let's go ahead and get it done. Everybody, what was that one thing I need to make sure I do before I multiply by a percent? What was that thing I need to do? Move that decimal. That's correct. Move that decimal. Everybody, quick question. 20% turns into what? Yep, 0.2, 0.20. Either way, it's still fine. You take that decimal place once, twice, and there it is. 0.2, 0.20 works as well. It's the same exact thing. And then you multiply that by 168. And so here's a little refresher again with multiplying with decimals, just to make sure you understand. So here, I'm going to take care of business. We've got 168 multiplied by 0.2. So step one, what you're going to do is just multiply. And you're going to ignore the decimals, okay? Ignore the decimal. We're going to come back to that later. So if we take care of business here, we're doing 168 times 2. 8 times 2, that's going to give us 16. 6 times 2, that's going to give us 12. Bring the 1, that's going to be 13. And then we got ourselves what? We've got 1 times 2, that's going to be 2. Carry that 1, it becomes a 3. Okay, so we have 3, 3, 6. Now here's step 2. Step 2 is going to be bring the decimal places back. So my first question is, just look at the first number. Do you see any decimals there? Not quite, right? You don't see any decimals there, so you're fine. You look down here, I see that we have 0.2. So you're going to count how many spaces it is to where you wouldn't see a decimal anymore. So what you would notice is that, hey, 1 decimal place, 1 decimal place. And so you bring back 1 decimal place. The answer would be 33.6. So again, if you had a decimal up top and on bottom, again, on the first number and the second number, you would count the total number of decimals. So we didn't have anything up top, so we were fine. But on the bottom there, that second number, 0.2, 1 decimal place, and that's what we're going to write down there. And so boom, we have 33.6, and that's what the answer would be. The result here, let me make sure you have enough room to take a screenshot if you'd like to, but the result is 33.6. So yes or no, does that make sense? Dana, absolutely. I got one thing to show you about this same exact problem briefly, and then I can do that for you for sure. For sure. All right, great, everybody. So there we are, right? So here's one thing I do want to, again, I got to make sure I do more of this, especially as your ASVAB coach, because if I can continue making sure that you understand the ideas from proportions and percent and how they're the same, I can show you like some pretty cool stuff. So remember earlier how we said, hey, if we were doing 50%, well, that's just cutting in half, right? From 100%, the original number, down to 50, that's cutting in half. Quick question, everybody. When it comes to 20%, is that a convenient number? Can you divide 100 by something to get down to 20%? Could you? Is there a number you could divide 100 by to get down to 20? If so, what is it? If so, what is it? Thanks for the appreciation, JB. Right, we can divide by 5. So pretty quickly here, again, just to help you understand the proportion idea that I'm talking about. And again, you got to be interested in this. I'm getting excited because I'm going to blow some minds here. But what I said earlier was that percents and proportions are the same idea. And it's because you're basically doing ratios based off of 100%, the whole thing. The original number is 100%. If you are trying to take 20% of a number, that means that you're going from 100, the original thing, down to 20. And when you think proportions, it's always with multiplication or division, always. And so if you're asking, how do I go from 100% to 20%? Well, if you divide 100 by 5, you get 20. So let's experiment real quick. Let me just show you what I'm talking about so I don't sound crazy. 20%, again, is the same thing as dividing by 5. So let me prove it to you and show you that this works. I'm going to divide 5 into the 168. And I'm not cheating you, right? That's 168 right there. The answer was 33.6. The answer shouldn't change. I'm not Houdini. I'm just the messenger. Watch this. 168. Everybody, how many times does 5 go into 1? Doesn't happen, right? Okay, how many times does 5 go into 16, everybody? 3 times. Excellent. Okay, 3 times right there. And so 5 times 3, that's 15. So we need to subtract 15. If you're not familiar with long division, I suggest you go back. I got plenty of YouTube videos. My program, if you're in there, you got plenty of practice. You got to work on that. But I'm going to walk you through here. Subtract the 15, you get the 1, bring down that 8. Everybody, how many times does 5 go into 18? Again, 3 times. Again, 3 times. Sounds good. Great. 3 times 5 is 15. We can go ahead and subtract that. We got ourselves a leftover of 3. Cool. Now, we still have a leftover, so we can keep dividing. We just got to make sure that we include the decimal place right there. And let me zoom in for us. That way, we don't think I'm cheating, right? You can still see everything. Okay. Let's bring down that 0. And that's going to be 30. Everyone, how many times does 5 go into 30? 33 point, again, put that decimal, exactly where it was, 33.6. Is that the same answer, everybody? It is, right? It is. And so this is the idea again. Percents and proportions, they're the same idea. They're literally the exact same concept. A percent is just a number in a different language. So you just have to translate a little bit, but it's literally the same exact idea. So to anybody out here, does that idea, is it starting to make a little bit of sense when I say that proportions and percents, same thing, typically? Yeah, and if you're not quite understanding where I'm coming from, that's cool. But I did expect quite a few of y'all to be like, oh crap, it does make sense. But there's a little bit of a holdback if you're always trying to think about it as a proportion. Remember this, the reason that this looks cool and looks awesome or whatever is because you had a convenient number. Like when you had 50%, oh yeah, that's just cutting 100 by 2, dividing by 2. 20%, divide by 5. 10%, divide by 10. If it's 5%, divide by 20. If it's 1%, divide by 100. And if you think about it that way, you can get away with really cutting a lot of time on some very straightforward questions. But what happens if you're dealing with 15%? What happens if you're dealing with 27% or 72%? Percents that aren't exactly convenient. That straightforward way will always work. Always works. I just want to let you know that if you're dealing with a convenient numbered situation, like a 10%, 5%, 1%, 2%, 50%, anything that you can really go straight forward to 100 with, hey, take advantage of it. Does that make sense, everybody? Again, it's not going to work in every single situation, but if you have a convenient situation, convenient percent, you can do some damage here. Okay. Good, good, good. I'm just going back, making sure I didn't miss any comments here too. Okay, looks like we're good. Good. All right, so let's practice this next one. And then after that, we have one quick little thing, and then we're getting straight into those word problems. So let's take a look at this one here. 40% of what number is 120? 40% of what number is 120? Everybody, what's your guess? Do you think we're looking for the percent here? Do you think we're looking for the original number or the result? What do you think we're looking for? And how do you know? How do you know? Again, give me a reason why. How do you know? Again, the most important thing, guys, remember, is knowing why. Knowing why is the most important thing. Always, always, always. I know we're looking for the original because 120 is the result. I love seeing that. Exactly. I love that you're referencing the formula there, Tia. Exactly. The percent times the original equals the result. And so if you look at this, everybody, look, 40%. So your percent of, the word of means to multiply. Then you see what number? Okay, I'm just going to draw a blank there. Equals, the word is means equals. And then this is where the result belongs, right? 120, this is where the result belongs. So that means that we don't have the original. If you check it out here, yeah, exactly. 40% of, so 40% times the original times what number? Blank, unknown. You're looking for the original number. Is 120, is the result. So 120 is the result. We're looking for that original number. Yes or no? Is this starting to make a little more sense to you in terms of knowing what you're looking for? Is this making a little more sense? Good, 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 good. So here's what we're going to do. We're going to solve this question, but one thing you're going to learn how to do or need to learn how to do is how to divide by decimals. Okay, this is definitely something that is very scary to a lot of people, but once you know the mechanics, clockwork. I promise you it's clockwork. So here we go. I'm going to say 40% times the original equals 120. Quick question, everybody. What do I need to do with that percent again? If I'm trying to set this up the right way, what do I need to do with that percent again? What do I need to do? Well, we're going to turn it into a decimal. Everybody, 40% is what as a decimal? Right? We can just write 0.4, right? 0.4, we're good. And so let me just illustrate this for you here. We're going to have ourselves 0.4 multiplied by the original amount. And that's going to equal 120. All right, quick question, everybody. What do we have to do to both sides to get the original number by itself? What do we have to do? Right, divide both sides by that 0.4. Divide both sides by that 0.4, and we are set. So here do we have? Divide this by 0.4. and there by 0.4. That's going to get eliminated, giving us, again, just the original number by itself. Original number equals blank, okay? And now, again, like I said, I warned you already, you got to know how to divide by decimals. Now, this is what I'm going to show you. It's a very, very quick, brief explanation. I'm not going to get too much into it because this is kind of its own little lesson, but the very simple rule is this. And tell me if this sounds familiar. In a fraction, whatever you do on top, you do to the bottom. True or false? With fractions, whatever you do to the top, you do to the bottom, right? Yeah. So everybody, if I am dividing by a decimal, it's not very wise to do that. You want to see it in a better way. And so you don't want to divide by a decimal because it looks like this. That's not as fun to look at because you don't know what you're supposed to do a lot of the times with that decimal. You might not know what to do with it. So the best situation is just don't divide by the decimal. And so what you're going to do is, hey, I'm going to take that decimal place right over here. I'm going to move it over because I would rather divide by 4. But remember, whatever you do to one part of the fraction, you do to the other. So if I move the decimal place on the bottom, I gotta move it up top. And so this right here, move it over one time. So all I'm saying is that 120 divided by 4.4 is the same thing as 1200 divided by 4. They're the same thing. Now, in case you don't agree with me, in case you're looking at me saying, hey, coach, that looks like voodoo, I don't believe you, let me prove it to you real quick so you can feel a little more confident, so we can sleep at night a little better, especially if you're watching the Jeff Dahmer documentary. So let's go ahead and take a look at this. Quick question. What is, let's say, 10 divided by 2? What is that, everybody? Right, it's 5. So let's suppose that we add a decimal to each one. Let's suppose we do that. If I do that from here to there, from here to there, that becomes 100 divided by 20. Everybody, what's 100 divided by 20? I did the same thing to the top and the bottom. What's 100 divided by 20? Hit me. Still 5, huh? Still 5. Still 5. 20 goes into 100 5 times. If I did it again and again and again and again, look, move it over again, that'd be 1,000 divided by 200. It's still going to give you the same result. 1,000 divided by 200 is still going to be 5. So I really want you to have confidence in knowing that if you're dividing by a decimal, you can give yourself an easier time by moving that decimal over until you're no longer dividing by a partial number. Make sure you get a whole number and then divide. Because if you do that, 120 divided by 0.4, being stumped there, being confused, nope, you can give yourself a much easier time. And if you understand that it's the same thing as 1200 divided by 4, you can easily look at the answer and say, 1200 divided by 4 is what? 300, exactly. So if you look at 120 divided by 0.4, you might not see that, obviously. But if you know how to move those decimals, 1200 divided by 4, boom, 300. I'm great, looking awesome. I feel good about myself, and I know how to work with these decimals. And so the original number here in this case would be 300. Could you cross the zeros at the end? You mean for these examples? Of course. Of course. Absolutely. Of course. But everybody, yes or no, does that make sense? Krishan is correct. Does that make sense, everybody? That when you're dividing by a decimal, which you will have to do at some point on the ASVAB, you can move the decimal place on what you're dividing by so you can divide by a whole number. Just make sure to move the same decimal places up top. Yeah, that was working backwards right there. Yeah, that was working backwards, that right there. We had to work backwards to find the original number. Yeah. Good. Okay, so it is 7:05, so we're going to kick it into high gear now. We are going to get into these word problems. I got to give you one last chance here to get some practice in. 15% of what number is 21? I want to give you exactly 2 minutes here to try this problem out. So remember, first thing you want to do, ask yourself, am I looking for the original or the result? Set it up, and then do your thing. All right, so I'm going to give you 2 minutes here to get that done. And then I didn't forget, I forgot who asked it, but I did not forget that I am going to give you an example, obviously, of, let me change this over to 2 minutes, that I am going to give you an example of multiplying where both numbers have a decimal place. Let's be real, my ASVAB party people. You're enjoying this YouTube video, but why don't you join me for a free class? I host a free class once a week for 2 hours. So imagine 2 hours of free ASVAB math instruction by yours truly. We get to ask questions, grow with me, raise your score, and get the job you want. So go ahead, click the link here or in the description to sign up for free. And from there, I'll see you in the next class. But until then, let's get back to the math party. Let's go and get into it here. 15% of what number is 21? Quick question. Are we looking for the result, the percent, the original? What is it? What are we looking for? Original. The original. Yes, that is what we're looking for. So let's get into it here. Set this up. The word is really what you want to tackle, what you want to track. Because everybody, what does the word is translate to? Hit me with it. The equal sign, that's correct. Bam. So we know that that's your equal sign right there. And remember, it's always going to be your percent times the original equals the result. So we are looking for the original. Everybody, quick question. If we're looking for the original, technically we're working backwards. What did I tell you earlier? If we're working backwards in a percent problem, are you going to be multiplying or dividing to get that final answer? Right, we're going to work backwards. We're going to divide. We're going to divide to get that original number. We got to work backwards because we got to get rid of the percent on the original number, and that's going to cause us to divide. Jessica, the answer to that is yes. We will be creating a decimal out of the percent to do this. Absolutely. So let's get into it. So 15%, everybody. Everybody, what should I write as a 15%? What's that going to be when I go ahead and convert it? Right, it's going to be 0.15. You move that decimal place over once, twice. So that's going to be 0.15. 0.15. All right. Then we don't know what the original number is. So I'm just going to say, times the original. I'm just going to leave that like that. Equals that result, which was again what? Correct, 21. Cool. So before I continue, this would have been the first step. The first step, again, is just understanding what you're looking for. There's no point in trying to calculate in a problem if you don't know what you're trying to find. So that's step one. So before I continue, even for those of us that were confused, even for those of us that didn't get an answer or a correct answer that you feel like, do you agree or disagree that you understand this problem is asking you to find the original number? Do you agree or disagree? And only say agree or yes if you can explain why. If you can actually really, explain why. Okay, good. Feeling pretty confident there. So with that, what did I say we need to do again to both sides? What do we need to do again to both sides? And don't worry, if you got stuck at the division portion, I got you. Right, yeah, we're going to need to divide. I just said it, right? We got to divide both sides by that 0.15. Because if you're trying to get this right here by itself, well, that's in the way. That's in the way. That 0.15 being multiplied, you got to get rid of it by dividing it. You work backwards to solve equations. So with that said, nice and easy. Boom, 0.15 being divided on both sides. Nice and easy. That gets eliminated. So we say, hey, the original number is going to be equal to, and if you look at that, you might be looking at that saying, hey, coach, how do you divide by a decimal? Right? How do you divide by a decimal? Well, the way you divide by a decimal is by not dividing by a decimal. You need to move those decimal places on the top and the bottom until you're not dividing by a decimal. So when I take a look over here, everybody, how many times should I move the decimal on the bottom? Right. We want to move it twice to the right to make it a whole number. The best way to divide is to be dividing by whole numbers. And remember, like I said, I proved it to you earlier. If you're just coming in a little late, I'm sorry, I'm not going to repeat the explanation, but whatever you do to the top or the bottom of a fraction, you do to the other side. So if I'm going to say, hey, 21 and 0.15, if I'm going to say, hey, move that once, twice over, same thing here, once, twice over. Quick question, everybody, with those empty spaces that I have right here, what number belongs in there again? Exactly, we got to put those zeros in there, right? We put those zeros in there. So this is the same thing as saying 2100 divided by 15. 2100 divided by 15. Does that look a lot easier? You tell me. Does that look a lot easier than dividing by decimal? As Jessica might say, huzzah, right? Exactly. So let's go ahead and take care of business here. You don't need to know mental math to do 2100 divided by 15. You can get there, but I'm also going to show you mental math where we can. So here, 15 divided into 2100. Everybody, 15 goes into 21 how many times? Right, just one time. 15 goes into 21 just one time. So let's go and place that right there just once. Subtract the 15, and that's going to give you 6 left over. Bring down that 0, and you've got 60. How many times does 15 go into 60? Four times, correct. 4 times, so minus 60, because again, that's a perfect fit. 15 times 4, that's going to be 60. If you didn't know that, don't worry. Mental math and your quick calculations is something you definitely want to work on if you expect success in the ASVAB, okay? So from there, boom, that's going to be 0. Bring down that last 0. Everybody, how many times does 15 go into 0? Right, that's just a 0 there. And so we have a final answer of 140. So if anyone here got an answer of 1.4, of 14, well, that tells me that you forgot to move the decimal places the correct amount of times. You knew what to do, you just made a small error in executing that plan. So you were on the right track, you were good. You just may have forgotten to work the decimals the right way. Anybody here got 1.4 or 14? And see how you actually are supposed to get it? Even 0.14. Cool. I love it. Yep, the original number is going to be 140. Now, I'm not going to go over the mental math way. I would have said, hey, dividing by 15, same thing as dividing by 3 and dividing by 5, because 3 times 5 is 15. That's mental math for another day. We're going to move forward here because I really want to get into how to do taxes and discounts. This is what this is why I'm doing 2 days of this, because I know that we couldn't possibly get the whole refresher and the follow-up on into it. So that's why tomorrow we're going to continue doing these word problems, okay? And as always, my party people, thanks for watching. You can subscribe with that button right there, and you can also see a link to a video just like this one right up there. But most importantly, if you want the program and you want to raise your score the right way, every step of the way with my support, there's that link at the bottom left. Go ahead, click that link, watch the video on how the program works, subscribe, and raise your score.